Question. DS. John saved a total of $50,000 for 1 year. The money saved was divided into two parts, with one part invested in a simple annual interest at the rate of A% per year, and the other part invested in a simple annual interest at the rate of B% per year. If the total interest made by the $50,000 for that year was $1,080, what is the value of A? Condition 1. The ratio of A to B is 3 to 4. Condition 2. The ratio of interest made at the rate of A% per year to interest made at the rate of B% per year was 1 to 2. Solution. Now we will solve this DS question using the variable approach. DS, 4 variables and 2 equations. Question. Condition 1, 1 equation. Condition 2, 1 equation. DS question with 4 variables and 2 equations. Let the original condition in a DS question contain 4 variables and 2 equations. Now, 4 variables and 2 equations would generally require 2 more equations to allow solving for the variables. We know that each condition would usually give us an equation, resulting in a total of 4 equations, 2 from the original condition and 1 each from condition 1 and condition 2. Since we need 2 more equations to match the numbers of variables and equations in the original condition, the resulting equal number of equations and variables should logically give us an answer C. Let's apply the 3 steps suggested previously. Follow the first step of the variable approach by modifying and rechecking the original condition and the question. We have to find the value of A if the money saved, $50,000, was divided into 2 parts, with one part invested in a simple annual interest at the rate of A% per year, and the other part invested in a simple annual interest at the rate of B% per year. This type of question regularly appears in the exam, so it is important to remember the question itself and the solving process. So we can make $P equal to the amount of money invested at the rate of A% per year, and $Q equal to the amount of money invested at the rate of B% per year. Then, we get 2 equations from the original information. So, $P plus $Q equals $50,000. And so, $P times of whole of A over 100 plus $Q times of whole of B over 100 equals $1,080. Follow the second and third step. From the original condition, we have 4 variables, P, Q, A, and B, and 2 equations. P plus Q equals 50,000, and P times whole of A over 100 plus Q times whole of B over 100 equals 1,080. To match the number of variables with the number of equations, we need 2 more equations. Since conditions 1 and 2 will provide 1 equation each, C would most likely be the answer. Recall 3 principles and choose C as the most likely answer. Let's take a look at both conditions together. Condition 1 tells us that A is to B equals 3 is to 4, which can be written as A over B equals 3 over 4, or B equals 4 times A whole over 3. Condition 2 tells us that P times of whole of A over 100 is 2. Q times of whole of B over 100 equals 1 is to 2, which can be written as P times A over Q times B equals 1 over 2. This then can be arranged to get Q equals 2 times of P times A whole over B. Substituting values from A over B equals 3 over 4, we get Q equals 2 times P times 3 whole over 4, or Q equals 3 times P whole over 2. Now substitute this value in P plus Q equals 50,000, then we get P plus 3 times P whole over 2 equals 50,000. Multiplying both sides by 2 gives us 5 times P equals 100,000, and so P equals 20,000. We know that P plus Q equals 50,000, so Q equals 30,000. We substitute P equals 20,000, Q equals 30,000, and B equals 4 times A whole over 3 in P times whole of A over 100 plus Q times of whole B over 100 equals 1,080. Then we get 20,000 times of whole of A over 100 plus 30,000 times of whole of 4 times A over 3 whole over 100 equals 1,080. Simplifying this gives us 200 times A plus 300 times of whole 4 times A whole over 3 equals 1,080. Further simplification gives us 200 times A plus 400 times A equals 1,080. Combining like terms yields 600 times A equals 1,080. So A equals 1.8. The answer is unique, so the conditions combined are sufficient. Do you think you can solve the question like this during the limited time you have on the test? Never. It's impossible. You should never use the conventional approach, as suggested by the official guide. Make sure to use the variable approach. Both conditions 1 and 2 together are sufficient. So C is the correct answer.